Okay, so the polyatomic ions that I asked you to remember were ammonium. You're on table E now, right? Okay, ammonium, right here. Nitrate, phosphate. I'm on the wrong chart. Ammonium, carbonate, nitrate, hydroxide, phosphate, and sulfate. Okay. And acetate. Sorry, I missed that one. Okay. Those are the most common ones. And what happens with these guys is they act as if they are one piece. So in a ionic compound, we had two pieces, simple, Ca and Br. We had the cation and we had the anion. And the cation had a charge like +2 and the anion had a charge like -1. And then we took these numbers and we brought them down and we made the formula. That's for a binary ionic compound. If we start to include polyatomic ions, the polyatomic ion itself acts as either the cation or the anion. Let's take sulfate, for example. Okay? Let's say we had calcium. Oops, I like this paper better. Let's say we had calcium +2, and we had sulfate, which is a -2. Everybody see the -2 on their table E. See where sulfate is? Right here? You see how it has a -2 charge? Okay. We are going to use that to bring down just like we did before. So here's my cation. Here's my anion. And we're going to take these numbers, just like we did before, and we're going to bring them down. And we're going to take this number and we're going to bring it down. These two numbers are the numbers I put there. This 4 belongs to the polyatomic ion. You don't touch that. It's like these guys are a little package and they stay a little package. These two numbers are the ones that we can now manipulate, right? So we can reduce them to 1 to 1. Just like we did when we did just calcium and oxygen. When we did calcium and oxygen, Ca +2 and O -2, we took this 2, whoops, that's not a highlighter. We took this 2 and we put it down here. We took this 2 and we put it down here. And then we reduced these 2. This SO4 stays as a whole group. So when I write the formula for this, we're going to write CaSO4 because the 2 and the 2 get reduced to 1 and 1. This is no longer a binary compound. It is what we now call a ternary compound. It's ternary because I have 3 or more elements in the compound. I have calcium, I have sulfur, and I have oxygen. Okay? When you have a ternary compound, there is probably going to be a polyatomic ion in there somewhere. You've got to find it. Okay? That's why knowing your 7 or 8 polyatomic ions becomes very important. Because if I write down something like AlPO4, it's a ternary compound. Where's the polyatomic ion? And PO4. Okay, this is the polyatomic ion. That 4 belongs to the PO. So, all right, let's name this because I hear whispers. Aluminum. And then the PO4 doesn't become phosphide because we're no longer dealing with a binary. We're going to name it, according to what its name is, phosphate. And you get that from table E because the PO4 is called a phosphate. So this is aluminum phosphate. Okay, let's try another one. What would we call this guy? His name is not Bob.
Sodium acetate.
Sodium, because that's the cation. And the anion, which I'll do in green, is this acetate. So it's sodium acetate. Okay, let's do, let's write a formula instead of me giving you the name. Let's say we have magnesium carbonate, and I want to write the formula for it. So what is magnesium going to look like? Mg. What is its charge? It's a cation, +2. Okay. What does carbonate look like? CO what? CO3. Okay, and I'm getting that from here. The carbonate is CO3. What is its charge? -2. Okay, so now what I've done is I've got the cation, the magnesium. I'll make that orange. And I've got the anion, which is the carbonate. And I'm going to take these numbers. The 2 is going to come down here, and the 2 is going to go down there. Those 2's are the ones that I reduce. I do not touch this 3. It belongs to the carbonate. This is a 2, this is a 2, so it becomes MgCO3, magnesium carbonate. Okay? How about aluminum? Hey, where's my pepper? Aluminum sulfate. This one's a little bit different now. Okay. What does aluminum look like? Al. What is its charge? +3. Okay. Sulfate is SO4 with a -2. I should have asked you that instead of just writing it down. But you're getting it right from table E. Okay? We're going to take this number, and it's going to become the subscript for the sulfate. We're going to take this number, and it's going to become the subscript for the aluminum. Can I reduce these any further? Nope. 2 to 3 is the lowest whole numbers that we can get. So we're going to end up with Al2SO43. Okay, now we've got a problem. This is telling me that I've got 2 aluminums and 3 sulfates. But right now, remember, not everybody has beautiful handwriting. If I were to read this, it would look like there's 43 O's. We can't have 43 O's. We need 3 SO4s. So we have to put this SO4 in parentheses, because then it tells me that there are 3 SO4s. We didn't have to do that on these because it was 1-to-1. But when there's multiple of that polyatomic ion, you have to put the polyatomic ion in parentheses so that the reader knows that there are 3 SO4s. If I expand this out, this is what it's looking like. I've got 2 aluminums with a +3 charge. I've got 3 SO4s, each one of those with a -2 charge. Now, these charges all add up to 0. +3, +3, -2, -2, -2. Does everybody see how the puzzle pieces are starting to fall into place? Okay, here's another one. calcium phosphate. Okay, so let's say you're given this. First thing you ask yourself, is it ionic or is it covalent? Well, no, don't ask yourself that. Is this a binary or a ternary compound? And how do you know? And how do you know? Use the polyatomic ion. It ends in 8, phosphate, right? If it just said calcium phosphide, then it would be binary. But it says phosphate, and it's one of those 7 or 8 that I asked you. I said you're going to have to recognize them. I know they're given to you on your periodic table, but it would take you way too long. So just know that phosphate is a polyatomic ion. All right, let's write the formula for this. Ca, what's its charge? +2. Phosphate, PO4 -3. Okay, so I'll just change colors here. That 2 becomes the subscript over here. That 3 becomes the subscript over here. Am I done? What do I have to do? Put parentheses. Good job, Ryan. Okay. Make sure that polyatomic ion, because you have multiple of them, goes in parentheses. Okay. One more. I'll go the other way. I want you to give me the name of it. Oh, sure. Maybe. That's the one we just did. Good? Okay. Say it loud like you mean it so I can hear you. Magnesium nitrate. Give yourself a gold star because you did awesome today. Okay. Magnesium nitrate. Any questions on this? Now we know binary. We know how to write the formula. We know how to write the name. We know ternary. We know how to write the formula. We know how to write the name.